Hi there, thanks so much for clicking on this video. In this video, I'm going to be going through all the key skills that you need to know in order to do as well as possible in your numerical reasoning tests. So in this video, I'm going to be going through the key topics such as fractions, percentages. Percentages, that is a huge topic area. I'll be talking you through percentages of an amount, percentage increases and decreases, equivalent percentages. We'll also be tackling ratio, currency conversions, and also going through some general reasoning skills where I'll go through some sample questions so that you can see me putting the skills into action. Now, obviously practice makes perfect, so I would thoroughly recommend you do as many practice tests as possible. And for me, there's no better place than numericalreasoningpracticetests.co.uk. So sign up to those tests. You do get the first one completely free of charge, and that way you'll be well prepared for your test. Now, without further ado, let's crack on with some numerical reasoning. Let's kick off with some fractions. Now, one of the most important skills with fractions is being able to simplify a fraction, which you often need to do in order to find the correct answer option. If we look at the first fraction, 16 out of 20, you might work out that 16/20ths is the answer and realise that 16 out of 20 is not available in the A, B, C, D options. And that's because the options will have simplified fractions. Now, 16 out of 20 can be simplified. Both the top and the bottom numbers are even, so we might as well just divide them by 2. 16 divided by 2 is 8, 20 divided by 2 is 10. Now, I still have even numbers. 8 divided by 2 is 4, and 10 divided by 2 is 5. So 16/20ths is 4/5, and 4/5 cannot be simplified anymore. Depending on how good your tables are, you might have noticed that 4 goes into 16. 16 divided by 4 takes you to 4, and 20 divided by 4 takes you to 5. But you really don't need to, well, you really shouldn't be stressing yourself about looking for the biggest number that you can divide the numbers in a fraction by. Just go for what is, for you, the most obvious number. So for some of you, it might be dividing by 4, in which case that's great. For some of you, it might just be dividing by 2 and then dividing by 2 again. Often with fractions, it's a lot easier just simplifying them 2 or 3 times, or as many times as you need to, rather than trying to simplify them in one go. That's perfectly fine. So if you notice they're even numbers, just divide them by 2, see what happens. Can you simplify them again? 30 out of 50, again, we've got even numbers, so you could divide top and bottom by 2. But I think the easiest thing to do is just divide by 10. Hopefully you've spotted that they're both in the 10 times table because they both have a 0. So if you've got the fraction 30 out of 50, just chop off the 0. Now we've got 3/5. And that's the same if it's 100, if it's hundredths as well. 400, 500ths. Again, just chop off 1 0 top and bottom, just chop off another 0 top and bottom, 4/5. Now 35 out of 50 or 35/50ths, again, ask yourself the question, what is the most obvious times table that these numbers belong to? Well, it's not the 2 times table, obviously, because we have an odd number here, but hopefully you've spotted that these are in the 5s. 35 divided by 5 is 7, 50 divided by 5 is 10, so 7/10, and that can't be cut down anymore. So I'm hoping that you will easily spot numbers which can be divided by 2, numbers that can be divided by 10, and numbers that can be divided by 5. Now, if you're looking at a number, let's say, or a fraction 18 out of 21, obviously can't be divided by 2 because we have an odd number here. Not divisible by 10 because they don't end in zeros, and they're not divisible by 5, but otherwise they would end in a 5 or a 0. So what are we going to do? If we can't divide by 2, let's try the next number up, which is a 3. 3's go into 18 and 3's go into 21. 18 divided by 3 is 6. 21 divided by 3 is 7. So 18 out of 21 can be simplified to 6/7. 42 out of 49, this is a bit nasty. So it can't be divided by 2, 10 or 5. So if it can't be divided by 2, can it be divided by 3? Well, 3's do go into 42, but they don't go into 49. So let's not bother with 3. What about 4? Well, they can't be divided by 4 because if they can be divided by 4, then we could have divided them by 2. So we'll skip 4. 5, well, we would have noticed at 5. Can we divide by 6? No, because if we can divide by 6, we could have divided by 2. So in other words, if they can't be divided by 2, we need to be forgetting about any even number. What we're going through now is, well, we're looking for our prime numbers. So how about a 7? Now, 7 is one of the nastier times tables, but 7 does go into 42. and 49. 42 divided by 7 is 6. 49 divided by 7 is 7. So 42 49ths is 6/7. If we look at this next one, 33 over 88, again, can't be divided by 2 or 3 or 5, or can't be divided by 7 either. So the next prime number after 7 is 11, but you might have noticed that these numbers are divisible by 11 because the 11 times table is quite easy to spot. 33 divided by 11 is 3, and 88 divided by 11 is 8. So that simplifies to 3/8, and again, cannot be simplified again. So let's have a look at a couple of worded questions. So these are relatively easy questions. So if we look at the first question, what fraction of employees worked additional hours in the month of October? Well, we know it's 32 out of 64. So let's just write that as a fraction, 32 out of 64. That is the correct answer, but we need to simplify it. Hopefully we've spotted that they're both divisible by 2 because they're both even numbers. So that becomes 16 over 32. We still have 2 even numbers, so let's divide by 2 again. That's 8 over 16. Still got 2 multiples of 2, 4/8, which is the same as divide by 2 again. 2 quarters, and again 2 quarters, that is the same as 1/2. Perhaps you even noticed, I don't expect you to know your 32 times table, but maybe you noticed that 32 is half of 64, in which case you might have gone directly from 32 out of 64 to the 1/2 there. But as I said before, it's okay to half them again, half the numbers again, keep going until you get to a stage where you cannot simplify them anymore. So in the second question, we need to be very careful because the question is asking what fraction of the customers do not use diesel. So I think the easiest thing to do is to work out the fraction that do use diesel, which is 21 out of 56. Now, we can't divide these by 2. They're not in the 5s, they're not in the 10s. So if you can't divide by 2, can we divide by 3? 3s don't go into 56. We've already eliminated 5. So let's try 7. Yeah, 7 goes into 21 3 times, and 7 goes into 56 8 times. So the fraction that do use diesel is 3/8. So therefore the fraction that do not use diesel is the opposite of 3/8, which is 5/8. Or alternatively, if you know that 21 use diesel, you can work out the number that do not use diesel, which is 56 minus 21, which is 35. And now we're looking to simplify 35 56ths. I think the maths is a little bit harder now because we've got a bigger number, and we've also had to do some subtraction. But again, dividing both numbers by 7, 35 divided by 7 is 5. And 56 divided by 7 is 8. Again, as I mentioned before, simplifying fractions a lot of the time is just down to having a good command of your times tables. Another crucial skill with fractions is being able to convert them into percentages. Now you can do this 2 ways. You can either do them in your head or using a calculator. Now on this slide, these ones here, well, you can definitely use the calculator, but because the numbers involved are quite nice, these ones you should be able to do quite quickly mentally. Now, a percentage is a fraction. % means out of 100. So a percentage is a fraction out of 100. So it's the equivalent fraction out of 100. So 21 out of 50 is the equivalent to what out of 100? Well, what we need to do is just think, right, 50 multiplied by what gives us 100? Well, clearly that's being doubled. So for an equivalent fraction, we need to double the top as well. So 21 out of 50 is the same as 42 out of 100. In other words, 42%. When you have the fraction out of 100, that is the percentage figure there. 12 out of 25, again, let's turn this into an equivalent fraction out of 100. 25 multiplied by 4 is 100, so we need to multiply the 12 by 4, which is 48, so that is 48%. 11 out of 20, again, to turn a 20 into a 100, we're multiplying by 5, so we need to multiply the top by 5 as well, and 11 times 5 is 55, so the answer is 55%. So if the denominator is 50, all you have to do is just double the top number. If the denominator is 25, you just need to multiply the top number by 4. And if it's out of 20, multiply the top number by 5. If it's out of 10, it's dead easy to turn it into a percentage, add a 0, top and bottom. So 3 out of 10, 30%. Could not be easier. 4/5 can be a bit of a problem. One way of looking at it is 5 multiplied by what gives you 100? Well, 5 times 20 gives you 100. So let's multiply 4 by 20. 4 20s are 80, so that is 80%. But I often tutor people to convert 4/5 into tenths. 4/5 is the same as 8/10, and 8/10 becomes 80 100ths, still 80%. Or you could do 4/5 is the same as 40 over 50, and then just doubling the top and the bottom, we get 80 over 100, 80%. Here are some useful ones that you should just know. I'm sure you all know that a half is 50%. Hopefully you know that a quarter is 25%. 1/5 is 20%. Again, this is, a lot of people don't know the fifths. Again, you could turn 1/5 into 2/10. 1/5 is the same as 2/10 and add a 0 top and bottom. 20 out of 100, so 20%. And the tenths are dead easy. Just add a 0 top and bottom. So a tenth is 10%. Really useful. If you have really nasty fractions like 6 out of 37, well, this is, well, it's not impossible, but it's just not worth trying to do it mentally. 37 does not go into 100, so it's going to be very difficult for us to know what we need to multiply the 6 by. So I would say for these ones, use a calculator. Now, in a fraction, this line means divide. So what we need to do is 6 divided by 37. And if you type into your calculator 6 divided by 37, you'll get a number that doesn't really look like the percentage. It looks far too small. That's because if you do 6 divided by 37, you have the decimal. So we need to multiply that by 100. And 6 divided by 37 multiplied by 100 is 16.21. The number keeps going for, well, quite a long time. Perhaps in a question they might ask you to round it to the nearest whole number, which would be 16%. 6 out of 21, again, 6 divided by 21 multiplied by 100 is the calculation, and that comes to a total of 28.5. Let's call that 29%, just rounding it to the nearest percentage. Don't stress about rounding it, though. You'll always be told in the question whether they want the answer to the nearest whole number or to one decimal place or whatever. So remember to convert a fraction to a percentage. If you've got a nice denominator, you could do it mentally, which might save you some time. But if you're using the calculator, it's top divided by bottom multiplied by 100. If you don't multiply by 100, you have the decimal equivalent of the fraction, and to convert the decimal to the percentage, you have to multiply by 100. So that's why it's top divided by bottom times 100. So let's have a look at a couple of questions here. Now, some of these we can probably do in our heads. It's a good idea to try and train yourself to do as much stuff in your head as possible. That will develop your numeracy. And even though you might feel like it's much slower than using a calculator, it might be one step backwards, but you might eventually be taking 2 steps forward. So persevere with mental techniques. So a company has 20 employees, 3 are part-time. What percentage are part-time? Well, that is 3 out of 20. So we need to convert this into a percentage, which is an equivalent fraction out of 100. 20 multiplied by 5 is 100, so we need to multiply the top by 5. So 15 out of 100, so 15%. Or if you're feeling lazy, using a calculator, 3 divided by 20 times 100, 15. In the second question, we'll just write it as a fraction, 39 out of 50. So we're converting this into a fraction out of 100. So as it's out of 50, we just need to double the top number. And 39 times 2, well, 2 40s are 80, so go back 2, that's 78, so 78%. With this next one, we've got 7,000 out of 25,000. Now we can simplify this fraction to 7 out of 25. It's still going to be the same percentage, and again, 25 times 4 is 100, so 7 times 4 is 28, so that is 28%. Really useful to know that you don't need to be stressing about these big numbers. Just get rid of the zeros. It's still the same percentage. If you like, try it out on your calculator. 7 divided by 25 times 100 versus 7,000 divided by 25,000 times 100. It's still 28. Now for this last one, we've got some pretty horrible numbers here. So 74 does not go into 100. So I would say definitely use the calculator, which would be 63 divided by 74 multiplied by 100. And I'm just going to round the answer. We've not been told how to give our answer, but I'm just going to round it to the nearest whole number. 85.1%, let's just call that 85%, shall we? So remember, using a calculator, top divided by bottom multiplied by 100. Okay, so let's move on to fractions of amounts. Half of 30, well, that's nice and easy, that's 15. All we're doing is we are dividing by 2. Half of something is chopping it in 2, so half of 42, divide 42 by 2 is 21. 1/3 of 30, we need to divide 30 by 3. 30 divided by 3 is 10. 1/5 of 55, 55 divided by 5, 11. So all we're doing is dividing by the number on the bottom, so 1/7 of 28, 28 divided by 7, which is 4. If you're working out 1/10 of something and it ends in a 0, just chop off the 0, so the answer is 43. In the next example, 1/10 of this number, 356, it does not end in a 0, so all we need to do is put a decimal point between the last two digits, so 35.6. 1/100th of something, we are just dividing by 100, in this case chopping off 2 zeros, so 1/100th of 3000 is simply 30. A lot of people seem to struggle when the number on the top is not 1. What we need to do here is divide the total by the number on the bottom and then multiply that answer by the number on the top. So 2/3 of 30 is 30 divided by 3, which is 10. 10 times 2, which is 20. So in other words, what we're doing here is we're working out 1/3 of 30, which is 10. So if 1/3 is 10, then 2/3 is going to be double that, 20. So that explains why we're dividing by the number on the bottom and then multiplying by the number on the top. 4/5 of 35 is 35 divided by 5 multiplied by 4. 35 divided by 5 is 7. 7 times 4 is 28. 5/6 of 66 is 66 divided by 6 multiplied by 5. 66 divided by 6 is 11. 11 5s, 55. 2/7 of 28 is 28 divided by 7. 4 times 2, 8. Let's have a look at a few worded questions. So a company has 55 employees, of which 2/5 work from home. How many employees work from home? So we're just trying to work out 2/5 of 55. So what we're going to do is 55 divided by 5, which is 11. 11 times 2, 22. In the second question, we're told that the manufacturer needs to make adjustments to 3/10 of this figure. So how many waistcoats do they not need? Got to be really careful with these questions. That word "not" changes it completely. So if they make adjustments to 3/10, then that means they do not make adjustments to the remaining 7/10. So basically we need to work out what 7/10 of 35,000 is. So what again are probably acceptable to use a calculator here. Although we can do the 35,000 divided by 10 in our heads, but multiplying by 7 we'll definitely need a calculator, I think, in which case you might as well use a calculator for the whole thing. So the calculation is 35,000 divided by the number on the bottom multiplied by the number on the top, and that comes to a total of 24,500 waistcoats. Calculating a percentage of an amount is a very, very important skill, and there are two ways to do it. You can do it with a calculator or without. Sometimes it's quicker without a calculator, so it's worth practicing some of the mental techniques involved. So first of all, I'm going to show you how to do some simple ones without using a calculator. Now, 10%, now remember that percent means out of 100. So 10% means 10 out of 100, and that can be simplified to 1/10. So all we're doing is we're working out 1/10 of 230. Divide it by 10, 23. Maybe it's easier, just remember 10% is you're just dividing it by 10. 10% of 150 is 15. So when the number ends in a 0 and you're working out 10%, just chop off the 0. If it doesn't end in a 0, then you need to put a decimal point between the two numbers on the right hand side. So 256 becomes 25.6. That is 10% of 256. If you know 10%, you can work out any multiple of 10%. So what is 20% of 350? Well, 10% is 35. So 20% is going to be 35 times 2, which is 70. 30% of 150? Well, 10% is 15. So 30% is going to be 3 times 15, which is 45. 40% of 310, well, 10% is 31. So 40% is going to be 31 times 4, which is 124. I'm not saying that 40% of 310 is something that I would expect you to do mentally, because that's still quite a tricky calculation, 31 times 4. So there's no shame in using the calculator for some of them. I'm just trying to show you lots of examples here. 50% of 360, well, hopefully you know that 50% is a half. Half of 360 is 180. I think it would be a bit silly to work out that 10% is 36 and then try to do 36 times 5. I'm sure you'll agree just halving that number is a lot easier. If we know 10%, we can work out 5%. So 10% of 240 is 24. So 5% is going to be half of 24, which is 12. 15%, now we're sort of verging on territory now where it's probably quicker to do it on a calculator, but 15% is a combination of 10% and 5%. 10% of 160 is 16, therefore 5% is 8. So 15% is 10% plus 5%, so it's 16 plus 8, which is 24. 25%, you could see that as two 10% and a 5%. And remember, the 5% is half of the 10% amount, but much easier if you are familiar with the fractional equivalent of 25%, which is 25% is 1/4. What's a quarter of 48? 48 divided by 4 is 12. So again, it's really handy to remember that 50% is half, 25% is a quarter, 75% 3/4, etc., etc. 1% is also quite easy to calculate. All you have to do is to divide the number by 100. So 1% of 440 is 4.4. 1% of 320 is 3.2. Although I know plenty of people that would struggle to divide these numbers by 100 and creating that decimal answer. 1% of 240, 240 divided by 100, 2.4. So if we know that 1% is 4.4, then we can work out 2%, which is 4.4 multiplied by 2, which is 8.8. If 1% of 160 is 1.6, then 3% is just 1.6 multiplied by 3, which is 4.8. Again, some of these questions probably would be easier with a calculator, but if you can learn some of these mental techniques and try to get used to them, then you might find that although you're taking one step backwards, you might be making 2 steps forwards in the future. Now here we've got a really horrible percentage figure, 37%, but the total is really nice. If I said to you what's 37% of 100, most people get really confused by this question, I've noticed, but 37% of 100 is 37. 23% of 100 is 23, 64% of 100, 64. Hopefully you're getting the pattern. So if 37% of 100 is 37, then 37% of 200 is going to be double that amount, and 37 multiplied by 2 is 74. 12% of 300, well, 12% of 100 is 12. So 12% of 300 is simply 12 times 3, which is 36. 18% of 100 is 18. So therefore 18% of 50, which is half, 100 is going to be half of 18, which is 9. So if you have a nasty percentage amount, but the total is a multiple of 100 or a factor of 100, then you can work out the percentage amount quite easily. Now we're moving on to calculator territory. Now, I'm always surprised by how many people prefer to do these sorts of questions mentally rather than using a calculator. What you need to type into a calculator is 0.37 multiplied by 268. All you have to do is just stick a 0 and a decimal point in front of the percentage figure. What we've got here, we call this the percentage multiplier. Now this is the decimal equivalent of the percentage amount. In other words, it's the percentage amount divided by 100. But you don't need to remember all of that. Just remember, just stick a 0 and a decimal point in front of the number if it's a 2-digit number. Now, this is really, really, really important. I guarantee you'll be needing to use this in your numerical reasoning test. I noticed that when I tutor people, they remember it for about 5 minutes, and then when I tutor them a week later, they haven't got a clue again. So you just got to make sure you stay on top of it. The calculation for 61% of 454 is 0.61 multiplied by 454. 40% of 257 is simply 0.40 multiplied by 257. But of course, you don't need that 0. That 0 is not doing anything. So the percentage multiplier for 40%, you can just call it 0.4. But it's absolutely fine if you want to keep that 0 in. It's not really causing a problem there. 7% of 452. Now the decimal equivalent of 7% is 0.07. So that's what we need to multiply 452 by. If you do 0.7, 0.7 is our multiplier for 70%. 70% is 0.70, but as I mentioned before, with the 40%, that doesn't need to be there. So 70% 0.7, but 7% 0.07. Now, I've not told you the answers to any of these. To be frank, I couldn't care less about the answers. It's just about making sure you know how to turn the percentage into its multiplier so that you can enter it on a calculator. So let's have a look at some examples. So a company has 850 employees, of which 20% have worked more than 5 years. So we need to work out 20% of 850. I think you can do this without a calculator. So 10% is 85. So 20% is 85 multiplied by 2, and 85 times 2 is 170. If you're using a calculator, then the multiplier for 20% is 0.2 or 0.20. Again, the 0 doesn't need to be there, times 850. So this second example, I would definitely recommend using a calculator because we've got a really nasty percentage figure and a really nasty amount, the 15,854. So our percentage multiplier for 36% is 0.36. Just stick a 0 and a decimal point in front of that number. Multiply that by the 15,854, and that gives us a total of £5,707.44. This third example, we just need to be careful that we've read the question carefully. 6% is 1 star, so 2 star or more is the remainder, which is 94%. So we want to work out 94% of 85,678. Remember, the multiplier for 94% is 0.94. So that's our calculation, 0.4 times 85,678. And that comes to a total of 80,537.32. Presumably, if this was an actual numerical reasoning test, they would ask you to round it to the nearest whole number. So that would round down to 80,537. Continuing with percentages, another really important skill that you need to be able to do is apply percentage increases and percentage decreases. Now, like most things, there's two ways to do it. You can either do them mentally when the numbers are nice, or you can use a calculator. Now, on this slide, the numbers are quite nice. If you were to increase £80 by 10%, all you need to do is work out 10% of 80 and add it to 80. 10% of 80 is 8. So add 8 to 80, 88. If you're increasing £2,000 by 10%, well, what's 10% of 2,000? That's 200. Add the 200 to the 2,000, that's 2,200. If you're increasing £400 by 20%, 10% of 400 is 40, so 20% is going to be 80. So we need to add 80 to the 400 to get 480. If we're increasing £80,000 by 50%, we need to work out 50% of 80,000, which is 40,000, and add that 40,000 to the 80,000 to get 120,000. If we're increasing by 1%, again, that's quite straightforward. What's 1% of 800? 1% of 800 is 8. So add 8 to 800 and we get 808. If we're increasing £125 by 1%, well, 1% of £125 is £1.25. So we need to increase 125 by £1.25, and that will give us £126.25. If we're increasing 5,000 by 2%, well, 1% is 50, so 2% is 100. So we need to increase 5,000 by 100, and that will give us £5,100. Now, using a calculator, again, you could do them mentally, but the numbers are not very nice. It would take a long time. So first of all, we need to work out 14% of 180. So what is 14% of 180? Hopefully you remember that the calculation is 0.14 multiplied by 180. So if we just type that into the calculator, 0.14 times 180 gives us an answer of 25 £1.20, which is what we need to add on to the 180. Now, rather than use this standard multiplier of 0.14, I'm going to use the multiplier 1.14. So all I'm going to do is I'm going to add 1 to our standard percentage multiplier, and this is the multiplier we use for a percentage increase. So if we just type into our calculators 1.14 multiplied by 180, that will take us automatically to the final answer, which is not 2520 but 180 plus the 2520, which is £205.20. So we need to really make sure we have a good understanding of percentage multipliers. If you're working out 14% of an amount, you'd use 0.14, but to increase by 14%, use 1.14. For the next one, 19%, our multiplier is 0.19, but this is an increase, so we're going to do 1.19 multiplied by £167, and whatever that answer comes to, I'm not going to actually bother working it out. Anyone can type buttons on a calculator. It's knowing what to type in that's the key. 64%, our basic multiplier is 0.64, but as we are increasing by 64%, the multiplier is 1.64 times the 2008, which equals whatever. 37%, our multiplier is 0.37, but for an increase, it's going to be 1.37 multiplied by 4009, and that takes us directly to the answer, whatever that is. So really important that you have a really good understanding of the difference between your basic percentage multipliers and the multipliers for a percentage increase. Now, decreasing by a percentage, again, it's exactly the same as increasing, except you're subtracting. So 10% of 80 is 8. 80 take away 8, 72. 10% of 2000 is 200. So subtract 200 from 2000, you're going to get 1,800. 20% of 400, well, 10% is 40, 20% is 80. So we need to subtract 80 from 400. So that's 320. 1% of 800 is 8. So take away 8 from 800. We're going to get 792. 1% of £125 is £1.25. Again, subtract the 125 from the £1.25 from the £125. 2% decreasing 5,000 by 2%. Well, 1% is 50. 2% is 100. Again, all we need to do is subtract £100 from the £5,000 and we are done. But when we are doing more complicated decreases, we can use percentage multipliers. Now, if you're shopping and you're buying something which is 14% off, what this means is you are therefore paying 86%. So all we need to do is to work out 86% of 180. The multiplier for 86% is 0.86. So 0.86 multiplied by 180, that is our calculation. And 0.86 multiplied by 180 gives us £154 and 80p. So it's really important we understand multipliers. For 14%, the multiplier is 0.14, but for an increase, the multiplier is 1.14, but for a decrease, it's 0.86. Now, a lot of people struggle with their comprehension of this multiplier here. Remember that if something is decreased by 14%, you are paying 86% of the original amount. So that's why you just need to calculate 86% in this case. Alternatively, if you don't understand that, then you're going to have to work out 14% of 180 and then subtract that amount from 180. If you're decreasing something by 19%, then that means you are going to be paying 100 minus 19, which is 81%. Our multiplier for 81% is 0.81 multiplied by 167. That's our calculation. If something's decreased by 64%, you're paying 36%. So we need to be working out 0.36 times by 2008. And if we are decreasing something by 37%, then that means we are going to, assuming that this is a buying scenario, which it may not be, but if something's reduced by 37%, you're paying 63%. So our question is now, what's 63% of 4009? 0.63 multiplied by 4009, which equals whatever, who cares? So here are a couple of worked examples. So we're told that a businessman has shares that have a value of this amount and they increase by 31%. The multiplier for 31% is 0.31, but for an increase, our multiplier is going to be 1.31. So our calculation is going to be 13,863 multiplied by 1.31. So I'm going to have to quickly reach for the calculator here. 13,863 times 1.31. That comes to a total of 18160.53. In the next example, the number of complaints has decreased by 15%. Therefore, the number of complaints is 85% of what it was before. Our multiplier for 85% is 0.85 multiplied by 660, and 660 times 0.85 is 561. So let's have a look at another example here. So here we've got two increases. So what we could do, the percentage multiplier for 16% is 0.16 and 12% is 0.12. But for an increase, it's going to be 1.16, 1.16 and 1.12. So after the first year, the shares will be 8,967 multiplied by 1.16, and that will give us our new value. And then this new value, we would multiply by 1.12 to give us our final answer. But there's a much quicker way. 8,967 multiplied by 1.16 multiplied by 1.12, because we really don't care what it is after the first year before it's increased again. So we can just do it all in one hit. So 8,967 multiplied by 1.16 times 1.12, which comes to a total of £11,649.93 to the nearest penny. Now, this is the kind of example where you can save a lot of time by just skipping some steps, really. Since we really don't care what the value is at this point here in the question, because we're only going to increase it by 12% again, you can do it all in one hit, and it just saves you having to hit the equals button. It's a lot smoother if you can just do it in one hit. And we can do the same with a decrease. If something decreases by 32%, then that means we are calculating 68%. So that's our multiplier for 68%. And then 18% means we need to calculate 82%, so 0.82. So here our calculation is simply 7,597 multiplied by 0.68 multiplied by 0.82. Again, doing it all in one hit, because we really don't care what the value is at this point here in the question. Since all we're going to do is reduce it by another 18%, we might as well reduce by 32 and 18% at the same time. And that gives us a final answer of £4,236.09. Percentage multipliers are quite tricky, but it's really worth getting your head around them. It's a really worthwhile investment, as it will save a lot of time when you're doing these numerical reasoning tests. So first of all, let's have a look at basic percentage multipliers first of all. So here the question might be, or the question that that is going on in your head when you're interpreting a question is, what is a certain percentage of a total? So 65%, the multiplier 0.65, 32%, 0.32. So if it's a two-digit percentage number, it's dead easy. All you need to do is just chuck a 0 and a decimal point in front of it. 8%, be careful when it's a single digit percentage number. It's not 0.8, because that would be the basic percentage multiplier for 80%. 8% is 0.08, and 1.2% is even more complicated. They can be really tricky when it's a percentage amount which is a decimal less than 10%. So 1.2 becomes 0.012. Now, if you're ever not sure to go from the percentage figure to your basic percentage multiplier, you just take the number and divide them by 100. Easy. Okay, so that's how you calculate a basic percentage of something. Now, assuming that you can get the basic percentage multiplier, the increase, the percentage multiplier for the increase is easy. You just add 1 to these numbers. So 0.65 is for calculating 65% of an amount, but for increasing by 65% of an amount, 1.65. 32% increase is 1.32. 8%, 1.08, and 1.2% is 1.012. And don't forget, the whole concept of why they're called multipliers is we have to, all these figures, we're multiplying them by the total. Now, the decrease multipliers are probably the hardest. Remember, if something reduces by 65%, then that means it is now 35% of what it was. So the question is now, what is 35% of the original total, which is why we're using the multiplier 0.35. If something is reduced by 32%, then that means it is now 68% of what it was originally, which is why we're using the multiplier 0.68. Sometimes the hardest bit is working out what 100 minus 32 is. 100 minus 8 is 92. So if something reduces by 8%, then that means it's 92% of what it was originally. So that's why we're multiplying the total by 0.92. If something is reduced by 1.2%, then 100 minus 1.2 is 98.8. So that means it is now 98.8% of what it was originally. And the multiplier for 98.8% is 98.8 divided by 100, which is the 0.988. So make sure you're on top of these. Maybe just to train yourself, just pick a number at random between 0 and 100. Let's just say 15. What's the basic multiplier for 15%? Easy, 0.15. For a 15% increase, 1.15. And for a 15% decrease, 100 take away 15 is 85, so 0.85. And remember, these are the figures that you would multiply by the total that you're trying to work out a percentage of, or to increase by a certain percentage, or decrease by in this case 15%. Calculating the percentage change, whether that's an increase or a decrease, is vital for your numerical reasoning test. And you need to remember the very simple formula, which is the difference between the two values divided by the original value multiplied by 100. But sometimes you get really easy questions and you don't really need to stress about the formula too much. As long as you put the difference and the original as a fraction, then you can probably turn it into a percentage quite easily. Let me show you some examples. So an employee's hourly rate has increased from £10 to £12. What is this as a percentage increase? Well, it's a difference of £2. It was originally £10. So it might be easier if I write 2 over 10 without the pound sign, so it looks a bit easier to read. What is that as a percentage? Well, 2/10, that is the same as 20 over 100, so that is a 20% increase. Alternatively, you can do 2 divided by 10 times 100, it will still give you 20%. So in the second example, it's a difference of 8. It was originally 10. 8 out of 10, that is the same as 80 out of 100, so that is an 80% increase. If an hourly rate is increased from £25 to £28, that's a difference of £3. The original amount was 25, and again, let's convert that into a percentage, which is the equivalent fraction out of 100. 25 goes into 100 4 times, so we need to multiply the top by 4. 3 4s are 12, so that is a 12% increase. Although feel free, 3 divided by 25 times 100 on the calculator is absolutely fine as well. This last example is an increase of £18 from 20. 18 out of 20 is the equivalent to what out of 100, or 20 goes into 105 times. 5 times 18 is 90, although working that out might be quite tough for most people, to be fair, so it's absolutely fine, I think, just to go 18 divided by 20 multiplied by 100. These ones weren't too bad because the denominator of the fraction, the original amount, was a nice figure, 20, 25 and 10, which are factors of 100. Decrease is exactly the same thing. Again, it's the difference divided by the original multiplied by 100, or just look at the fraction and convert it into a percentage. So here the difference is 1. It was originally 10. 1 out of 10 is the same as 10 out of 100, which is 10%. 10 to 6, that's a drop of 4. From 10, that's 40%. 25 to 16, that is a decrease of 9 from 25. And again, 25 goes into 100 4 times, so 9 times 4 is 36. So that's a 36% decrease. Or if you like, 9 divided by 25 times 100 using that formula. 20 to 8, that's a drop of 12 from 20. Again, turning that into a percentage, which is the equivalent fraction out of 100. 20 goes into 100 5 times. 5 12s are 60. So that is a 60% decrease. So these are some slightly harder questions where I'd say you definitely need to use a calculator. So remember the formula, which is the difference divided by the original value multiplied by 100. So what is the difference between 32,800 and 24,456? That is a difference of 8344. The original value was, well, what did it increase from? It increased from the 24456. So 8344 divided by 24456 times 100, should have written that in, tells us that that is, to the nearest whole number, that's 34. That's a 34% increase. This next example, again, let's work out the difference, but we can forget the thousands. I mean, you can keep them in if you want, but 191 minus 120 is 71. What was it originally? It was 120 before it was increased. And as long as I'm consistent with my ignoring of the those 3 zeros, we're fine here. So 71 divided by 120 times 100 tells us that that is a 59% increase. If you want to put the zeros in, then that's going to be a difference of 71,000 divided by 120,000, but it's still going to work out 59%. Again, knowing some of these tricks, that how to ignore digits, is it going to save you loads of time? No, but you know, every little helps, doesn't it? Okay, let's have a look at this one here. So here we've been told that sales of Mars bars decreased from 13,000 to 12,200. So that is a drop of 800 Mars bars from the original amount, which was 13,000. If you want, you can cancel 2 zeros top and bottom just to make it slightly easier typing it into your calculator, but there's no huge advantage really. And 8 divided by 130 times 100, that equals 6.1. Let's just call that 6. That's a 6% decrease. So let's have a look at this next question. So here is the percentage loss. So that's just the decrease in the value of the car. So it's gone from 32 to 25,000. So that is a difference of 7,000. It was originally 32,000. So that's our calculation. Again, you can keep the 3 zeros on the 7,000 if you want, but 7 divided by 32 times 100 is the same as 7,000 divided by 32,000 times 100, and it will still work out as just under 22%. So this is the sort of question you might get in a numerical reasoning test. So what was the percentage decrease in the value of stock C? Well, let's find stock C. Stock C is the blue line. Quarter 1 to quarter 2 is these values here. So it's the decrease from 322 to 127. So first of all, we need to work out the difference. 322 minus £1.67, that is £1.55. It's decreased from the £3.22. So that's our calculation. 155 divided by £3.22 times 100. That is a 48% decrease. Let's have a look at stock A. Stock A is the dark pink line, so this one here, from quarter 3 to quarter 4. So it's increased quite a lot. So again, what is the difference between £2.88 and £1.05? That's a difference of £1.83, and it's increased from £1.05. So 183 divided by £1.05 times by 100 is 174%. Now, a lot of people will not really like this answer because they'll feel that a percentage should always be less than 100. So they'll probably put £1.05 on top and 183 on the bottom and get a completely wrong answer. When something doubles in value, that is a 100% increase. If something was £25 and you've sold it for £50, you have made a 100% profit because the profit you made is the 100% value of what it was originally. So when something doubles in value, that is a 100% increase. So in this case, it must have more than doubled. And as you can see, £1.05, £2.10, £3.15, it's nearly tripled in value, which is why we're close to 200% here. So for a percentage increase, the percentage figure can literally be any value at all. So don't be alarmed if it's more than 100%. Let's take a look at this final question on percentage increases and decreases. So we've been told that the 2012 value was 8,234. 2013, it's gone up to 12,456. And then in 2014, it's gone up again to 13,134. And we need to work out the overall increase in value as a percentage. Now, a lot of people might panic because there's a lot of, well, there's 3 sets of numbers here that you might work out the percentage increase from 12 to 13 and then work out the next increase from 13 to 14. So you've got 2 percentage increases here. And maybe you would, I don't know, what would you do with those 2 percentage increases? Would you take the average of them? Would you add them together? Well, both would be completely wrong. These 2013 figures are completely irrelevant. We're just interested in the overall increase, which is the increase from 2012 to 2014. Doesn't matter what's gone on in between. It doesn't matter if it's gone down then up, or up then down, or up a little bit and up a little bit more. We're just looking at the difference between that value and that value. So again, now it's fairly straightforward, same as all the other ones we've been doing. 13,134 minus 8,234, that's the difference, 4,900, divided by what it was originally, which was the 8,234, and multiply that by 100, and that works out to the nearest whole number. That is a 60% increase. So don't forget the formula, difference divided by the original value multiplied by 100, and that's the same whether you're calculating an increase or a decrease. So the final thing on the topic of percentages is equivalent percentages. Now these range from easy to hard. Let's start off with a very quick, easy example. Now, I'm an extremely generous man, and every year I donate 50% of my salary to charity, and last year I donated a grand total of £200,000 to charity. As I say, I'm an extremely generous man. Now, just from me giving you that fact, I bet you're thinking, oh my God, that means this guy earns £400,000 in total. I wish. So I told you before that I donate 50%, which is half my salary, to charity. So therefore my whole salary, which is the 100% amount, is 400,000. Easy. You know that 100% is double 50%. So if I told you that 50% is 200,000, then the full amount, the 100%, is 2 times 200,000, 400,000. So that's an equivalent percentage, working out 100% when you've been told what 50% is. So here we go. If 50% is 560, then 100%, well, 100% is double 50%. So it's going to be 2 times 560, which is 1,120. If 20% is £30, what is 100%? Well, 100% is 5 times more than 20%. So we need to work out 5 times 30. 5 30s are 150. If 25% is 40,000, then 100% is 4 times more than 25%. So we want 4 times 40,000, which equals 160,000. And if 10% is 85, then 100%, that is 10 times more than 10%. So 100% is going to be 10 times 85, which is 850. So these are nice and easy. We were working out 100% from from factors of 100. So let's have a look at some more. If 20% is 560, well, 40%, that's double 20%, so double 560, 1,120. 5% is 40,000, 25%, well, that is 5 times greater than 5, so it's 40 times 5, so £200,000 is 25%. If 6% is 85, what is 60%? Well, 60% is 10 times greater than 85. So we need to multiply 85 by 10. So 60% is 850. 20% is £60. So 80% is 4 times greater than 20. So 4 lots of 60, 240. If 8% is 110, then 24%. 24 is 3 times greater than 8. So we need to multiply 110 by 3. So that is 330. So far, so good. Because the percentage figures we've been needing to calculate are multiples of the percentage amount we have been given. So these ones are a bit trickier. So 37% equals 560. We want to work out 100%. Now 37 is not a factor of 100. So what I'm going to do is I'm going to work out 1%. So if 37% is 560, then 1% is going to be 560 divided by 37. And that comes to a total of £15 and 14p. Although it's quite a long decimal answer, but I'm just going to keep it in the calculator for now, rather than round it. Because now, if 1% is this figure here, 100% is this amount here multiplied by 100. And again, by not pressing delete on my calculator, I don't need to worry about any rounding. So I can just simply multiply that by 100, and I get the answer of £1,513 and 51p. So with the difficult ones, we need to work out 1% and then turn it into 100%. So in the next one, if 23% is 30, then 1% is going to be 30 divided by 23. So 100% is going to be 30 divided by 23 multiplied by 100. And 30 divided by 23 times 100 comes to a total of £130, 43p. So it's exactly the same for all the other ones here. So I'm not actually going to bother working out the final answer. But if 87% is this amount here, then 1% is 40,000 divided by 87. So therefore 100% is going to be our 1% amount, which is this, 40,000 divided by 87 multiplied by 100, because 100% is 100 times greater than 1%. If 18% is £85, then 1% is going to be 85 divided by 18. So 100% is going to be this amount here times by 100. So 85 divided by 18 multiplied by 100. So all we're doing, we can't go from 18 to 100. We can't go from 87 to 100 or 23 to 100 directly, but we can work it out if we work out what 1% is first. And it doesn't have to be a 100% amount. If 37% equals 560, then 1% is 560 divided by 37. Therefore, 45% is 560 divided by 37 times 45. Practice this a few times and you'll get really, really fluent. So for example, the next one is going to be £30 divided by 23 multiplied by 12. That's your 1%. That's your 12%. The next one is going to be 40,000 divided by 57 to give me 1%. Multiply that by 25 to give me 25%. The final example, £85 divided by 18 gives me 1%. Multiply 1% by 73 gives me my 73%. Job done. So let's have a look at this question. These are all quite similar. So we're told that this amount here equals 45%. And we want to work out 38% that's invested somewhere else. So the calculation is we're going to work out what 1% is. So if this is 45%, then 1% is going to be 112,800 divided by 45. And if that is 2,506, and then we're just going to multiply that by 38%. We're going to multiply that by 38. And that tells me that in bonds, he has 95,253 to the nearest pound. For the second example, I mean, these are all fairly similar. This amount here equals 41%. So I'm going to work out what 1% is, which is 12,800 divided by 41. We want his overall share portfolio, so therefore that means the 100%. So I've just calculated 1% by doing 12,800 divided by 41, and if I multiply that by 100, I'll get the overall amount, which is £31,219.51. So let's have a look at the final example here. So a supermarket sells various brands of cereal. Brand A is 13% of the total. Brand B is 31% of the total. How much revenue is generated by brand B if brand A generates a total of 32,880 presumably pounds? So brand A is 13%, so we know that 13% equals 32,880, and we want to work out 31%. So what I'm going to do is I'm going to work out 1%. So 1% is going to be the 32,880 divided by 13. So 31% is going to be 32,880 divided by 13 multiplied by 31. And I'm just going to need a calculator for that. Obviously 32,880 divided by 13 times 31 comes to a total of £78,406 to the nearest pound. Over the years as a maths tutor, one thing I've really noticed is that so many people struggle at maths because they don't have a good understanding of the relationship between fractions, decimals and percentages. It's really, really important to get a grasp of this. Now, let's start off with some basic values. Now, I'm sure you all know that a half is 50%, and you no doubt know that 50% is a half. And you probably know that it's 0.5 as well. But do you know that 50% is the same as 0.5? Do you know how to interchange between decimals and percentages? To go from the decimal to a percentage, you're just multiplying by 100. Percentage to the decimal, you're dividing by 100. If you want to convert the fraction to the decimal, it's just top divided by the bottom. So to go from the fraction to the percentage, it's top divided by bottom multiplied by 100. So on your calculator, 1 divided by 2 gives you 0.5. 1 divided by 2 multiplied by 100 gives you the 50. But in this slide here, I'm not really showing you how to go from fractions to decimals, decimals to percentages. I'm just making sure that you're aware of some really common values. Just learn these if you're not aware of them. A quarter is 0.25, 25%. You probably knew that one. 3/4 is 0.75, which is 75%. Now, a third, it's worth knowing, which is 0.3 recurring, otherwise known as the percentage value of 33.3 recurring percent. I only mention this because you might end up with a calculation on your calculator, and your calculator will give you an answer which is 14.33333. Do you know that that is 14 1/3? Because 14 1/3 might be one of the answer options. So knowing that 0.3 recurring is a third is really handy. And if 0.3 recurring is 1/3, then 0.6 recurring is 2/3. So 16.66666, that's 16 2/3. And again, multiply the decimal by 100 takes you to the percentage. So the percentage equivalent of 2/3 is 66.6 recurring percent. 1/5, that is 0.2, which is 20%. 1/10 is 0.1, which is 10%. Now, a lot of people really struggle with understanding place value when there's a decimal point. The first column after a decimal point represents tenths. So 0.1, that's 1/10. 0.2, that's 2/10. 0.3, that's 3/10. You might be thinking, hang on a second, you just told me that 0.2 was 1/5. Yes, that's correct. 0.2 is 2/10, and 2/10 simplifies to 1/5. When there are two decimal places, we are now talking about 1/100ths. We're talking about hundredths. So 0.01, that is 1/100th. 0.02, 200ths. 0.03, 300ths. 0.17 is 1700ths. So make sure you're familiar with all of these common equivalencies here. So these are some of the ones that it's expected that you know off the top of your head without having to reach for a calculator, and it will speed things up if you know automatically that a something 0.75 is something and 3/4. And again, moving on from that, you need to learn how to go from fractions to decimals. That's top divided by bottom. Decimals to percentage, multiply by 100. Percentages to decimals is divide by 100. And percentages to fractions, well, remember that the percentage is the fraction out of 100. So 50% is 50 out of 100. And eventually you can simplify that down to 1/2. Let's move on to ratio. Now, one of the easiest skills involving ratios is simplifying a ratio. Ratios can be simplified in exactly the same way that fractions can be simplified, and it's a fairly similar technique. All we're doing is we're looking for a number that we can divide both numbers by. So in the first example, we have the ratio 4:2. 4 and 2 are both even numbers, so we can divide them both by 2. 4 divided by 2 is 2. 2 divided by 2 is 1, so that's a ratio of 2:1. 20:8, divide both by 2 again, that's 10:4, and we can divide by 2 again, which is 5:2. Of course, if you recognise that 20 and 8 are in the 4 times table, then it's absolutely fine to divide 20 by 4, which will give you the 5, and 8 by 4 to give you the 2. But I know from experience from working with numerous students over the years that not everyone has a good grasp of tables, and often it's quicker using more steps but using easier steps, and that will get you to the answer more safely and quicker. So in this example, probably easier to divide it by 2 twice rather than working out whether you can divide it by 4, and then some people would struggle to divide by 4 as well. 40:60, we can simplify that straight away to 4:6 by chopping off the zeros. So we've just divided that ratio by 10, and we've got 2 even numbers, so that is 2:3. 48:36, there's probably quite a big number that goes into 48 and 36, but maybe I don't know what that is, but I've noticed they're both even, so let's divide by 2. 24:18, divide by 2 again. 12:9, I can't divide by 2 now because 9 is an odd number, so I'll try 3. 12 divided by 3 is 4, 9 divided by 3 is 3. Of course, if you've spotted that 48 and 36 are multiples of 12, then you can just divide this ratio by 12. 48 divided by 12 will give you the 4. 36 divided by 12 will give you the 3. A three-way ratio is not any harder. Again, same thing. What can we divide 27, 30 and 54 by? Obviously not 2 because 27 is odd. What about 3? 27 divided by 3 is 9. 30 divided by 3 is 10. 54 divided by 3, you'd probably need a calculator for that, but the answer is 18. Can you simplify this again? No, you can't, because there's no number that you can divide 9, 10 and 18 by. Let's take a look now at an example. So in this question, we've been told that a businessman has £56,000 invested in company A and £42,000 invested in company B. So we need to write this as a ratio. So the ratio is going to be company A to company B. So therefore the amount in company A will go on the left of the colon and B to the right. Now we can write this as a very simple ratio. So 56,000 to 42,000. Now straight away we can divide both of these numbers by 1,000 without any thought whatsoever. It would be a mistake at this stage to divide by 2. Let's just chop off the 3 zeros both sides. So our ratio is now 56 to 42. Now again, it's all about times table recognition. My times tables are pretty sharp, so I can go straight to the simplified ratio from here, but you might struggle because it's quite an obscure times table here. But we know they're both even numbers, so let's divide by 2. 56 divided by 2 is 28. You might need a calculator. And 42 divided by 2 is 21. So at this stage, we now need to simplify 28 to 21. Well, we can't divide by 2 because 21 is odd. So let's try a 3, but 3s don't go into 28. They do go into 21, but not 28. That's no good. No point trying 4 because if they can be divided by 4, then they would have been able to be divided by 2. Let's try a 5. Neither of these numbers are in the 5 times table. 6, they're not in the sixes, because if they were in the sixes, we could have divided them by 2. So basically, we can eliminate any even number. So what we're looking for odd numbers, the prime numbers. So let's try a 7. Yes, both divisible by 7. 28 divided by 7 is 4. And 21 divided by 7 is 3. So the ratio company A to company B is 4:3. The next skill with ratios is sharing a total. What you need to do is turn the ratio into fractions. So if we're dividing £48 or sharing £48 in the ratio of 2:1, let's call them person A and person B. Person A will receive 2/3 and person B will receive 1/3. Now you might be thinking, hang on, where are these thirds coming from? It's not always thirds, just in this example it's thirds because 2 plus 1 is 3. So person B gets 1/3 of 48, so person B will get £16, and person A will get 2/3, which is double the 16, which is 32. And 32 plus 16 gives us the 48. Person A in the next example will get 4/5, and person B 1/5. We're dealing with fifths because 4 plus 1 is 5. So person A will receive 4/5 of 40, and person B will receive 1/5 of 40. Well, 1/5 of 40 is £8. So if 1/5 is 8, 4/5 is going to be 4/8, which is 32. And again, 32 plus 8 equals the 40. So we know we've allocated the funds correctly. In the next example, we're dealing with ninths because 7 plus 2 is 9. So person A will receive 7/9 of 90. So really this skill just reinforces the fraction of an amount. What is 7/9 of 90? 90 divided by 9, which is 10, times 7, which is 70. And person B 2/9, which is 90 divided by 9 times 2, which is 20. Here's a three-way ratio. It's no more difficult than a two-way. Again, add the numbers up. 2 plus 3 plus 1. We're dealing with sixths. And if you want, you can change the 2/6 to 1/3 if you simplify it, and 3/6 is a half. It might be easier, but it doesn't matter. So person A will receive 1/3 of 72. So that is 72 divided by 3, which is £24. Alternatively, 72 divided by 6 times by 2. The person B will be a half of 72, which is £36. Alternatively, 72 divided by 6 times by 3. And person C, 1/6, which is simply 72 divided by 6, which is £12. Final example, 6 plus 5 plus 1 is 12. So we're dealing in twelfths here. Person A, we can simplify that to a half if we want. So if person A gets a half, which is the same as 6/12, then person A will get 60. Person B, 5/12, so that is 120 divided by 12 times 5, which is 50. And to be honest, at this stage, if you're feeling like you never make a mistake, person C, you can just simply 60 plus 50 is 110, so there's £10 left over, or you can just work out a 1/12 of 120. It's up to you. So let's have a look at this example. So a businessman has a total of $56,000 invested in company A and company B in a ratio of 3:5. So what that means is in company A he has 3/8 of his total investment and company B 5/8. So if we're interested in company A, we're just trying to work out 3/8 of 56,000. Can actually do this in our heads if you want. So 56, easier if you just ignore the zeros for now. 56 divided by 8 is 7, times 3 is 21, so that is 21,000. Of course, it's okay to use a calculator, but do try to get out of the habit of using a calculator, because you will find that as your numeracy improves, you can do it quicker in your head than you can punching the buttons in on a calculator. Scaling a ratio up is the opposite to simplifying a ratio. If I've got a ratio 4:3, then I can scale that up 8:6. I've just doubled it. I could triple that ratio. 4 times 3 is 12. 3 times 3 is 9. As long as I perform the same multiplication to both numbers in the ratio, then it's a scaled up ratio. Let's take a number at random. Let's say 50. 4 times 50 is 200. 3 times 50 is 150. All of these ratios are exactly the same, but 4:3 is the ratio in its simplified form. Now in this first example, we know that Leah and Zach have shares in a ratio of 2:3. but Leah has 20 shares. Now that is 10 times more than the simplified ratio, so therefore Zach must have 10 times greater than the corresponding figure for his share. 3 times 10 is 30. So if Leah has 20, Zach must have 30. All we've done is scaled the ratio up 10 times. Let's have a look at the next example, 7 to 9, but this time it's Zach that's got the 45, so his is the right-hand figure. 9 times 5 is 45, so we're scaling the ratio up 5 times. 7 times 5 is 35. Here the ratio is 1 to 4. Leah has 14 shares, so we're scaling the ratio up 14 times. So here we need to do 14 times 4, or 4 times 14, which is 56. So if Leah has 14 shares, Zach must have 56 shares for it to be in the same ratio. Here are some worded questions. So company A and B have a ratio of 4 to 3. Company A sells 8,000 computers. So we are scaling the ratio up. Now I don't know by how many times we need to multiply 4 by to turn it into 8,000. So to work out what that multiplier must be, I'm going to divide 8,000 by 4. 8,000 divided by 4 is 2,000. So therefore 4 times 2,000 is 8,000. So we're scaling this ratio up 2,000 times. And 3 multiplied by 2,000 is 6,000. So company B sells 6,000 computers. In this final example, the ratio of A to B is 7 to 3. Supplier B makes a profit of 51,000. So how many times are we scaling the ratio up? I don't know how many 3's go into 51,000. So to work that out, I'm going to do 51,000 divided by 3, which is 17,000. So we're scaling this ratio up 17,000 times. 3 times 17,000 is 51,000. So therefore I need to multiply the 7 by 17,000 as well, and 7 times 17,000 is £119,000. You may be asked to write a ratio in terms of 1 to n, where n is a number that you need to work out. Now here 1 is on the left hand side, so what we're going to do is we are going to divide both numbers in the ratio by the number on the left hand side, because 22 divided by 22, that will give me the 1 that we're after. So therefore for an equivalent ratio we need to divide the 35 by the 22 as well, and that is 1.59 to 2 decimal places. Again, don't worry about how many decimal places, the test will tell you what they want. So in the second example, 1 is on the left, so we're dividing both numbers by the left-hand number. 125 divided by 125 will give us the 1. So the right-hand number is going to be 362 divided by 125, which is 2.896. So all I've done here is we have an equivalent ratio, just where the number on the left is the number 1. The next example, if you want, you can just simplify that ratio, saving you having to type in all the zeros into your calculator. Again, we're going to divide both numbers by 105 because that will give me 1 on the left, and on the right hand side 937 divided by 105 is 8.92, so that's a ratio of 1 to 8.92. And in this final example we're going to be dividing both numbers by 3.14. 3.14 divided by 3.14 is 1. Anything divided by itself is always 1. So on the right hand side we just need to work out what 9.356 divided by 3.14 is, and that comes to approximately 2.98. You might be asked for a ratio in terms of n to 1, where the n is the left hand number. Because 1 is on the right, we're going to be dividing both numbers by the number on the right. So in this one, 83 divided by 83, anything divided by itself gives us that 1. So 37 divided by 83 is the other number, and 37 divided by 83 is 0.44 to 2, well, no, that's be 0.45 to 2 decimal places. But anyway, we don't need to stress about the number of decimal places. Let's just get the technique sorted. So again, we're dividing both numbers in the second example by 190. That will give me the 1 on the right hand side. 1034 divided by 190 is approximately 5.44. On this example, we're dividing both numbers by 7.2. 7.2 divided by 7.2 gives me the 1 that we're after. and 9.7 divided by 7.2 is 1.34. And on this final example, again, as it's the right-hand number that we're turning into a 1, that means we need to divide both numbers by 34.09, which gives me 1 on the right. And on the left, 12.7 divided by 34.09 comes to 0.37. So here's an example, a worded example. So we know the ratio is 23,000 fridges to 12,000 dishwashers. So we want to turn it into a ratio of 1 to n. So first of all, we can just simplify this ratio to 23 to 12. Let's just write it a bit more neatly over here, 23 to 12. So we want to turn this into a ratio of 1 to n. Now 1 is on the left, so we're going to divide both numbers by the left-hand number, which is the 23, because 23 divided by 23 gives me the 1. So our n value is going to be 12 divided by 23, which is 0.52. So that's a ratio of 1 to 0.52 to 2 decimal places. In the second example, the ratio is 2567 to 8957, and we want a ratio of something to 1. The 1 is on the right hand side, so we need to divide both by that right hand number. And we know that 8957 divided by itself will give us the 1. So we just need to work out the 2567 divided by 8957, and that comes to a total of 0.29 to 2 decimal places. Okay, so now let's take a look at some currency conversions. For conversions, I always give people the tip, which is to divide by the same, multiply by the difference. Now, this might not seem very helpful at the moment, but hopefully once you pick up what I'm talking about, it'll make life very easy. And I think it's most likely that in numerical reasoning you'll be converting currency, but this also works if you're converting kilometers to miles, gallons to liters, any conversion whatsoever. Now, here we've got a conversion rate, an exchange rate, and we want to convert 254 Canadian dollars. So 254 Canadian dollars. Now, dividing by the same means we need to divide by Canadian dollars. So we are looking for the Canadian dollar value from our conversion rate, which is 1.73. That's what I mean by divide by the same. We're converting dollars, Canadian dollars, so we need to divide Canadian dollars by Canadian dollars. And multiply by the different, well, what's different to the dollars? In this question, it's the pounds, so we need to multiply by the pounds number, which is 1. So here, that's what I mean by dividing by the same, multiplying by the different. Dollars divided by dollars times by pounds. Of course, when you've got the number 1 in a conversion rate, it's you can often skip one of the steps. Here, multiplying by 1 isn't going to change the answer in any way, shape or form, but 254 divided by 1.73, you can multiply it by 1 if you want, but that gives us £146.83. Here we're going the other way, so we're converting pounds to dollars, so dividing by the same means dividing pounds by pounds and then multiplying by Canadian dollars. So we need to divide by the pound value from the conversion rate, which is 1, and multiplying by Canadian dollars, 1.73. Again, dividing by 1 can be skipped, but you can do 1200 divided by 1 if you want, but then we're multiplying that by 1.73, and that comes to 2,076 Canadian dollars. Here we've got a slightly more complicated conversion rate, but it's the same principle. Remember, divide by the same, multiply by different. So here we've got Bitcoin, so we need to divide by the Bitcoin value, which is 50, and then we're multiplying by what's different to Bitcoin, which is dollars, which is 1,871,000. So 1,300 divided by 50 multiplied by 1871000 equals a huge number, and this is going to be in dollars, 4864600. So I'll just put some commas in, so 48,646,000. For B, let's write 5.6 million as a proper number, so let's write it like that in full. So that's dollars, so dividing by the same means we're dividing by dollars, So we're dividing by 1,871,000, and then we're multiplying by 50. Of course, when you're doing this calculation and you see some zeros top and bottom, you can simplify it just to save a bit of typing into the calculator. But if you're not confident doing that, that's fine. Just type the number in full. I'm just trying to think of ways, helpful ways to try and save a few precious seconds in a numerical reasoning test. So here we've divided dollars by dollars. That's dividing by the same, multiplying by the different, multiplying by the Bitcoin, and that comes to 149.65 Bitcoin. In this example here, we're converting dollars to yen. I mean, it doesn't really matter what the currencies are, but the issue here is we don't have a conversion rate for dollars to yen, just dollars to pounds, pounds to yen. So I'm going to need to convert the dollars into pounds first of all. So dollars divided by dollars multiplied by pounds, dividing by the same, remember, and then multiplying by different. So the dollars from the conversion rate is 1 and the pounds is 0.82. So 1200 divided by 1 is 1200. We can skip that step. Times 0.82 is 984 pounds. And now we need to convert that into yen. So pounds divided by pounds multiplied by yen. Again, we're dividing by 1, which is fairly pointless, and then multiplying by 350 yen. And that comes to a total of quite a large number, 344,400 yen. So sometimes you have to convert from one currency into another via a third currency. Let's have a look at this question here. This is quite similar to the example that we've just gone through. So we're converting 350,000 US into Canadian, and we're going to have to turn it into Indian rupees first of all. So remember, divide by same, multiply by different. So we're going to be doing $350,000. So we're going to be dollars divided by dollars multiplied by Indian rupees. So 350,000 divided by 1 multiplied by 74. Again, dividing by 1 can be skipped, and that comes to a total of a huge number. I think it's 25,900,000 rupees. And now we need to convert that into Canadian. So we need to divide rupees by rupees, which is this number divided by 58, and then multiplying by Canadian dollars, which is multiplying by 1. Again, we can skip the multiplying by 1 because that's not going to change this answer here. So 25,900,000 divided by 58 Indian rupees gives us a total of, and remember this is a total in Canadian dollars, and that's going to be, I'll better put a C there to show it's Canadian dollars, not US dollars, 446,551.72. Again, in the question, they might say round it to the nearest dollar or to the nearest cent, but for now, this will do. So let's take a look at some actual reasoning skills. Let's do some sample questions and see some of the skills in action. Now, I don't know how you feel, but I often feel really overwhelmed when I see the first numerical reasoning question. It's always a very confusing graph or table. You don't know what any of it means or what it even relates to, and that's completely normal. On the first question, you're still getting a feel for the data, but hopefully by the third and fourth questions, you're starting to get a bit more comprehension of what actually the data is showing us here. Anyway, in this question here, the question is, as a percentage, which shares have increased the most from the 2020 value to the current value? It's probably worth just, scanning through the data briefly before you even look at the question. So, okay, we've got 5 companies, we've got a 2020 share price, a current share price, so these are their values in pounds, and we've got an exchange rate, blah, blah, blah. Okay, great. I'm not really sure what I'm going to be doing with any of this, but it will unfold as the question goes along. So maybe just a quick bit of research before you hit the question is a good idea, but not for too long because obviously the clock is ticking. So as a percentage, which shares have increased the most from 2020 value to the current value? So I need to find the 2020 value. Right, that's dead easy. That's that column here. And the current value, dead easy. So all I'm doing is I'm looking at these 2 columns and I'm looking at the shares that have increased the most, but not in terms of value, but as a percentage. So here I'm working out what the percentage increase is for say company A going from 123.42 to 156.32. Now, just scanning through it here, there's 5 companies, there's only 4 options, and if you look at company D, it hasn't increased at all, it has decreased. So company D, we're wasting our time if we're trying to work that one out. Plus, it's not even an answer option. So all you need to do now is just think, right, how do you do a percentage increase? Well, it's the difference divided by the original multiplied by 100. So company A, we need to subtract 123.42 from 156.32, which is 32.9, and that we're going to be dividing by 123.42 times 100, and that comes to 26.6%. Although on your calculator it will say 26.6 and the numbers continue for ages, I'm sure 26.6 is enough. I'd be very, very surprised if another company was 26.6 and a very similar long decimal. So we can probably one decimal place, I mean, not even rounding it, literally just truncating it after one decimal place is going to be more than adequate. Maybe even the nearest whole number is fine too. Company B, so all we're doing is exactly the same thing for company B, company C, and for company E. So B, the difference between the two values is 46.57, which we're dividing by 256.32 times by 100. So there's a lot of calculations, but it's the same calculation every time. So we can sort of build up a bit of speed now just by repeating the process multiple times, and that's 18.1%. C, the difference is 24.24, and that we're dividing by the 118.32 times by 100. That comes to 20%. So at the moment A is in the lead, and D, what the difference is 12.72. Sorry, it's not D, that's company E, isn't it? 12.72 divided by 89.63 multiplied by 100, and that comes to 14%. So clearly the biggest increase is company A. So on to the second question. Hopefully, having done the first question and played around with the data a little bit, we've got a better understanding of what the data is all about. This was not the most complicated set of data. It's just 5 companies, their share price in 2020 and their share price today. Most of the companies, their share price has gone up, one went down, and we've also got some exchange rates which might be used in one of the later questions. So let's have a read of this question. A businessman has got 1,200 shares invested in Company A, Company B, and Company E in a ratio of 4 to 3 to 5. So before I read on, I know I'm dealing with Company A, Company B, and Company E. So we can forget C and D. So forget that. And we also know the ratio is 4, 3, 5. 4 plus 3 plus 5 is 12. So we know that Company A is going to be 4/12. Company B is 3/12 of the total, and Company C is 5/12. So if he has 1,200 shares in total, we can work out how many shares he's got for A, B, and C. Right, what do we need to actually do for the question? What is the current value of his shares? Okay, so if I can work out how many shares he's got in A, B, C, all I need to do is multiply it by the share price and add them up, and we're done. So 4/12, if you see 4/12 as a third, just to make things a bit quicker, but you don't have to simplify the fractions. Since you're using a calculator, your calculator can handle slightly bigger numbers without any effort. So you don't have to break it down to 1/3 and 1/4. But we just need to work out 1/3 or 4/12 of 1,200, which is 400. So he has 400 shares in A. In B, it's 1/4 of 1,200 or 3/12 of 1,200, which is 300. And for Company C, 5/12 of 1,200, so that's 1,200 divided by 12 times 5, which is 500. Now, earlier in the video, I always added up these numbers to check that they added up to 1,200, but hopefully by now you're confident, and I would say it's a bit of a waste of precious time if you just add these three just to check they add up to 1,200. So the Company A share price, it's the current value we're after. So again, we're not interested in this column either. So it's just 156.32 multiplied by 400. That comes to 62528. For B, it's going to be the 302.89 multiplied by 300, which is 9 0.0867, and the last one is going to be multiplied by 500, and that comes to 51175. And we know we're going to be adding these numbers up, so just to save a tiny bit of time, rather than this presumably is the last answer you've had in your calculator, so rather than clear it and then add these three numbers up, if that is your answer from the previous question, then simply add the 90867 to it and the 62528, just so it saves a bit of typing. You know, that could be 5 to 10 seconds saved, and we've got a final answer which is 204570, which is answer B. So on to question 3, and question 3 is a really good example of a very worded question that seems so confusing with lots of percentages, lots of things to do. It can be a bit overwhelming, but if you just go through the question and read between the lines, ask yourself questions at various points. So I'll show you what I mean. Company A's 2020 share price increased by 23% from the 2019 value. So here I'm going to ask myself that question. Okay, the question is, what was the 2019 value? Because that's obviously going to be useful later on. So we know that the 2019 value was increased by 23% rather. So it was multiplied by 1.23. 1.23 is our multiplier for a 23% increase. And that resulted in it now being valued at 123.42. So if the 2019 value times 1.23 gives us the new value, then the 2019 value is going to be 123.42 divided by 1.23. We're just rearranging this equation a little bit. When you move something from one side of an equation to another, it becomes the opposite. So now we can work out the share price in 2019, and that would have been £100 and 34p. Now your calculator display goes on for ages. Don't stress yourself by writing down everything on your calculator display. How you round it is not going to be terribly important. I mean, don't be ridiculously sloppy. I don't think calling it £100 is acceptable, but you know, 100.34, 100.35, 100.33, even though we're going to be doing a tiny bit of rounding for a few values, you can see the actual answers are very, very different. So it's unlikely we're going to accidentally hit the wrong answer. We might not get these answers bang on, but we might get pretty close to it. Now, so we've now worked out the 2019 value, and company C's share price fell by 16%. So company C, if it decreased by 16%, then that means it was therefore 84% of what it was originally. So we would be multiplying that by 0.84 to get this value of 118.32. So therefore the 2019 value, a bit like what we've done before, it's just going to be 118.32 divided by 0.84. Therefore its value in 2019 was £140.86. So we've not even understood what we need to do for the question yet, but we've worked out what the prices were in 2019. So if a person bought 60 shares of each in 2019, what's the difference between their combined value in 2019 and their current value? So this, we're going to work out the value in 2019. So what we could do 100.34 times 60, 140.86 times 60 and add them together, but much quicker is just add these two numbers together and then multiply that by 60. So 100.34 plus 140.86 equals whatever, times that by 60. That tells us that in 2019 the 60 shares of each were worth 14472. And now we just need to do exactly the same thing for 2020. 60 shares of each now have a value of these two values added together times 60, 156.32 plus 142.56 equals whatever. Who cares what that value is, because we're just multiplying it by 60, and that is 17932.80. That's in 2020. So all we are doing is just subtracting one from another. Since we've got this value in our calculator, we it'd be silly to clear it just to type it back in again. So just hit minus 14472 and we've got our answer of 3460.8, which is answer D. So I'm guessing one of the key shortcuts here would be not doing 60 times 156.3 to 60 times 142.56, add them together, then multiply by 60. And we've saved ourselves a lot of time by doing that shortcut twice. So for question number 4, we've been told that Steve buys 26,412 euros of Company D shares in 2020, and we need to work out what they're worth in pounds now. Now, obviously, we haven't used the conversion table yet, so obviously it's going to be coming into effect in this question. So the problem is we know how much Steve's shares are worth, but we don't know how many shares he has. So first of all, we know we're talking about Company D, so we can forget all the other rows completely. We're just focusing in on Company D. So he has 26,412 euros worth of shares, and they are £62 per share. Well, £62 and euros, there's a bit of a problem. So first of all, we're going to need to convert that into pounds or the share price into euros. I'm going to convert the value of his shares into pounds. So what we have here is 26,412 euros. So remember, when we're doing a conversion, we divide by the same. This is the conversion rate we're using because we are looking at 2020. So euros divided by euros multiplied by pounds in this case, and 26,412 divided by 1.42. That comes to a total of £18,600. So Steve's shares had a value of £18,600, but still we don't know how many shares he had, but we know that they were £62 each. So if we work out how many £62 there are in £18,600, then we'll know how many shares he has. In other words, let's divide this by 62. And that comes to 300. So Steve has 300 shares. So we know if he has 300 shares, and we want to know how much they're worth in pounds now. So the current share price is £49.52. So we just simply need to multiply that by 300, and that will give us a total of £14,856. Not much to do in that one really, except just trying to find a way to solve the question. Again, thinking about the fact that we've not used the exchange rates at all in any of the other questions tells us that they weren't just put in there for a laugh. There was a reason someone went to the effort to produce this table. So this is when they come into effect in this final question. So thank you very much for watching. I hope that was of use to you. This might be a video you might want to watch again and again a few more times just to revise or just focus on a particular topic. And don't forget, practice makes perfect. So do some actual practice tests where you can find some at www.numericalreasoningpracticetest.co.uk. And remember, there is a complete numerical reasoning test free of charge on there. So go and sign up today. Thanks for watching.